Welcome to lesson 12.2. We're going to continue talking about parabolas in this lesson. Specifically, we're going to talk about something called concave up and concave down. And this describes the shape of the graph. So your aim today is that you can determine if a parabola is going to be concave up or concave down by looking at the sign, whether it's positive or negative, of the leading coefficient. So that's something we're going to talk about today. The graphs of quadratic functions are more complex than linear and exponential because they include a turning point, that vertex, that place where it goes from increasing to decreasing. That turning point is either the location of a maximum or a minimum, right? If it's a turning downwards, it's going to be a maximum. If it's turning upwards, it's going to be a minimum. Today we will explore these functions more by using our calculator. But first we need to examine one additional quadratic function by hand. So in the last lesson we looked at the function y equaled x squared. And that function looked like this, okay? Well, now we're going to talk about this function, and the only difference is that it has a negative, okay? So y equals negative x squared. So letter A says, write this parabola in the form y equals 8x squared, where a is the leading coefficient, and then fill out the table below. Okay, so what it's trying to say is that, what would a be here? Well, a would be negative 1x squared. Okay, so a is negative 1. Remember, we always have those invisible 1s right here? There's like a little invisible 1 in front of that. So this is like saying negative 1x squared. So when I fill out this table, I'm going to have y equals negative 3 squared, which gives me negative 9. So my point would be negative 3, negative 9. The next one, y equals negative 2 squared, so I have negative 4. So negative 2, negative 4. We're going to continue plugging in these x values and simplifying and getting our points. Negative 0 squared is just 0. You can't have a negative 0, so this point is just 0, 0. Now we're getting to positive values. What's going to end up happening, though, is these are still going to become negative because we have that negative in front for a, so I'm still going to have that negative y value. Negative 2 squared is negative 4, so I have 2, negative 4, and finally I have a 3, and it's negative 3 squared, so I get negative 9. Notice the repeating numbers pattern, negative 9, negative 4, negative 1, 0, and then it repeats, negative 1, negative 4, negative 9. That's always going to happen with quadratics. You'll have that repeating pattern. Okay, so now we're going to graph these points. So the first point is negative 3, negative 9. That's going to be here. So that's that point. Negative 2, negative 4 is right here. Negative 1, negative 1 is here. And 0, 0 is right here. Now I'm going to do the other side. They're going to be symmetrical. 2, negative 4 and 3, negative 9. Oh, this point, sorry, should be here. Sorry, let me get my eraser. Okay. This point should be here. There we go. 3, negative 9. Okay. Now we're gonna, I did it again here. I'm making graphing errors. There we go. There we go. Now we can see that we're forming a curve. And the only difference with this curve is look how it's facing. Do you see how on this one right here is going up? Well, we call this concave up. So what do you think we call this kind of shape? We call it concave down. And what's the major difference between these two graphs? The negative. So our rule of thumb here is that when you have a negative in front, it's going to go down like this. When you have a positive in front, it's going to go up. Okay? So that's the pattern we're thinking about today, is this positive versus negative shape of our parabola. Okay? So this last question wants us to talk about the range of this. Well, we've done this a couple times in the last lesson. Remember, your range is from your up and your down, right? Range is your y values, and it goes from top to bottom. Okay, so I know my range is going to look like this. Well, what's the very lowest y gets? It's going to go all the way to negative infinity. It's going to keep going. So negative infinity, what's the maximum it gets to? This point right here at 0, where y is 0. So my range is negative infinity to 0. You could also write it as this notation here, if you wanted to. There's several different ways to notate range and domain. Okay. Some parabolas are concave up, they open upward, and some are concave down, they open downward. Let's see if we can find the pattern. And I already kind of explained the pattern. If it's positive, it goes up, and if it's negative, it goes down. But let's take a look at this in our calculator, just to double check. So exercise 2, use your graphing calculator with a standard window to sketch each of the following. So let's get my calculator app open. I'm going to make this, minimize it here. Oops. Okay, so I'm going to go to my calculator. I'm going to go to graph. I'm going to type in my function. So this first function I'm going to do is this y equals 3x squared plus 6x minus 4. So I'm going to type that into my calculator. So 3x squared plus 6x, so plus 6x, and then minus 4. So I'm plugging that in my calculator. I'm going to hit enter. And it wants my window to be from negative 10 to 10. And right now it's going left to right, negative 10 to 10, but it's not going left to right, up and down 10 to 10. It's not a big deal. We can change this window to window settings and change this number here to being a negative 10 and a positive 10. So negative 10, and then I'm going to change this to being a positive 10. Okay. Oops, I didn't mean to. No, auto, okay. Okay, now it's got the same window as my graph. Okay. So I'm going to sketch this. If you want to see the grid lines better, something you can do is go to View, and then Grid, and then Lined Grid, and you can kind of see the grid a little bit better. Okay, so I'm just going to do a rough sketch of this. I can see that I'm going to start with the turning point. The turning point is about right here in my sketch, and it kind of goes a little bit past here. So here is my graph. It's not a great sketch. I'm not good at sketching, but you're not trying to be perfect, right? We're just making a sketch. Okay, so now I'm going to graph my second one on here. No, I don't want to change. I want to add graph. So now I'm going to do the next one. So the next one is y equals negative x squared plus 6x minus plus 1. So I'm going to go enter in negative x squared, don't forget your negative, plus 6x plus 1. And hit enter. And now I can see that my graph, I still need to get that window to be negative 10, 10. And for some reason these calculators do not do that automatically. I don't really know why. Okay, so we want my y minimum to be negative 10 and the y max to be 10. You might have to do this each time. Okay, and there we go. Now I can see that my vertex is all the way at the 10 at the top. So here on my graph, I'm going to put the vertex at 10, and it goes through here at 1, and it goes down. I'm not drawing this very well here. Like that. Okay, it should be a curve like this. Okay. All right, and finally, let's do the last one. All right, so I'm gonna hit. Actually, you know what? A better way to do this is hit Tab, and then hit your cursor up. Sorry, Tab. Hit your cursor up, and then you can just delete this entry. That way, we don't have to change the window every time. And then we'll just retype it in. Negative 2x squared minus 8x minus 4. Hit enter, and then the new graph will appear in that window. I can see my vertex is about right here on my sketch, and it's going down this way. Okay, so here are the three graphs I've sketched. Okay, and let's notice something really important here. Let me make this bigger. So notice that in my three sketches, some patterns. Here, let me use a different color for this so you can see a little bit. Let's use purple. So notice that I have a negative here. Oh, that's the bell. I have a negative here and a negative here, and both of these go which way? Down. They both go concave down because there's that negative in front. Is there a negative in front of here? No, this is positive 3, so it's going to go concave up. Okay, so that's the pattern we're seeing. That negative determines whether something goes up or whether it goes down. All right, this is going down, down, and this is going up. Also, something else to notice here, and some more vocabulary, is when you have something concave down, the turning point is going to be a maximum. This is a maximum. This, on the other hand, is going to be what? This is a minimum. Okay? So when something is concave up, it has a minimum. When it's concave down, it has a maximum. So this is some vocabulary that we need to start thinking about when we're looking at quadratic functions. Okay? So let's take a look at some more graphs here in these patterns. So what I want you to do is open up your calculators again if you're doing this in class, which most of you probably are based on how often you all do your homework. And we're going to take a look at some other interesting patterns, okay? Notice that all 6 of these equations they just have the x squared, right? They don't have the plus 2x plus 1 or whatever else. There's a really interesting thing that happens when the number in front gets bigger and smaller. And that's what we're going to look at here. So do you see how in this first one, here I'll underline it, we have a 2, and then the next one a 3, and the next one is a 4. We're going to see something really interesting happening with the shape. So for this next exercise, you're thinking about the shape. Okay? So let's plug them into the calculator. All right? So let's hit tab here, hit the cursor up, and then delete our old equation and type in our new one. So our new one is 2x squared. Enter. Okay? 2x squared is going to be a quadratic that starts at the vertex and goes up. So let's make our sketch. Be really careful at the sketch here. So it kind of looks like this. Okay. Now let's do the next one. The next one I'm going to show with a new. I'm just going to put it in the second one so you can kind of see how it's changing. And the next one, I'm not going to delete the old one. I'm going to do this one over the same graph. So the next one is 3x squared. Look what happened to the new graph. What did it do? It got skinnier, right? So this next graph got a little bit skinnier. It's going up a little sharper, right? And the last one, let's hit tab again and make a third one on here. 4x squared, and hit enter. It gets even skinnier. See how one's inside the other? So what's happening here? What's happening is that as the leading coefficient gets bigger, we get skinnier. Okay, so to sum this up a little bit here, okay, that for A, B, and C, as A gets bigger, the graph gets narrower. Okay, really important that it's going to get skinnier and skinnier, more narrow and more narrow. All right? And you can see that really clearly in the 3 graphs overlapping each other. So what happens when it's negative and it does the same thing? Will the pattern stay the same? Well, let's take a look. So I'm going to hit Control N and get myself a new graph here. Okay, I'm going to change my window just to prepare because I want this 10 to 10 like the thing wants. So I'm going to change the window, get -10 to +10. Why isn't that typing it in there? There we go. Okay, hit OK, and now I'm going to type in my function, -2x squared. So the only difference with this one is which direction should it be facing. Okay, it's going to be negative, so now we're going to have a concave down graph. So -2x squared is almost identical to 2x, is identical in every way to 2x squared, except it's going to be facing down. Okay, so I'm going to get my pen, and I'm going to draw a very similar graph to the red one, except it's going to be going down. Okay. I'm going to hit tab, open up a new line, and type in now negative 3x squared. It should be exactly the same. Oh, sorry about the bells. So it should be exactly the same, except that now it's going down. I hit enter and look at that. It's still just skinnier because it's the number in front's getting bigger. 3, 4 is getting bigger, so it's going to be skinnier, the same way the first one was. So it's just now it's concave down, but now it's just a little bit skinnier. Okay? And the last one, if we can predicting that it's going to be exactly the same, except, oops, there we go. It's going to be exactly the same, except it's going to be going concave down. Negative 4. What is happening with my graph here? Oh, I just moved it. Here, let's get it. Let's undo this here. Sorry guys, give me a second. So negative 2x squared was our first one. Then we had negative 3x squared. And now our last one is negative 4x squared. Sorry about that. See how it's just getting skinnier and skinnier? Same shape going concave down, but it's just getting skinny. So this is a really important lesson to think about when you're thinking about what A means in terms of the standard formula. Okay? Alright, as A gets bigger, the graph gets narrower. Alright? Something else to think about in terms of quadratics, if we can go back for a second, make this full screen. If we can go back to this, there's also something else interesting happening here. If you take a look at this number on the end, the negative 4, that's always going to be your y-intercept. Okay? And if I had graphed this a little bit better, you would have seen this green one would go through here at negative 4. So it should go like that. Okay? So that's going to be your y-intercept every time. So here's your y-intercept at, let me make it blue. Your y-intercept is here at 0, negative 4. Okay? Here your y-intercept is going to be at 0, 1. Right? That's your y-intercept. And here your y-intercept is going to be at negative 4. So that's always the case. Okay? So if we can make some rules here on the very last page. We're going to make some rules. So it appears that we can determine what controls the direction a parabola opens. So for this form, for ax squared plus bx plus c, here's our formula. Let's fill in the blanks. The parabola will open upwards, in other words, look like this upward shape, if a is positive. Okay? This type will have a minimum y value. Okay? This is a minimum. This is called concave up. And that happens when a is positive. Okay? Let me make this a different color here so we're not confused. And for the opposite, the parabola will open downwards, and other words look like this. This is concave down if a is negative. It will have a maximum y value. So here's your maximum. I also want to point out, and the lesson doesn't do this, but I want this to be part of the lesson, when you have ax squared plus bx plus c, this right here is your y-intercept. Okay? It's the place where the graph crosses the y-axis. So here would be your y-intercept at c. Okay? So graphing quadratics should be pretty easy with your calculators. You can also always make a table. If you have trouble using the calculators, you know where to go. You can ask either me or Ms. Samru for whoever you want help with. Okay? Good luck on your fluency and good luck on your mastery.